Let us write a C++ program to demonstrate DFS or Depth First Search Traversal in a graph. The objective of this program is to implement the traversal of graph using DFS. The operating system used is Windows 7 32-bit. The software used to write the program is C++ compiler Turbo C++. Some common instructions while using compiler IDE are: always press the Enter key to go to a new line. To compile the program, press Alt and F9, and to run the program, press Ctrl and F9. While we open the C++ compiler, we get a blank file by default to type in the program. To get the new page, select the File option in the menu and select New. To save the file with the name, press F2 and type in the required file name and press Enter key. Let us first learn what is graph and what does DFS or Depth First Search mean. A graph is a pictorial representation of a set of objects where some pairs of objects are connected by links. The interconnected objects are represented by points termed as vertices, and the links that connect the vertices are called edges. DFS is an algorithm for traversing or searching a graph. One starts at the root by selecting some node as the root in the graph and explores as far as possible along each branch before backtracking. Let us start writing the program. First, we type the preprocessor command iostream.h. This command is an object-oriented library that provides input and output functionality using streams. Next, we type the command which declares the library for console input or output functions. Then, we use ctype, which declares a set of functions to classify and transform individual characters. Next, we use structure to represent a graph node. Structures are user-defined data type available in C++ that allows us to combine data items of different kinds. To define a structure, we use the struct statement. Here, the name of the structure is node. Now, within the struct block, let us define its variables. First, we declare integer variable status and character variable data. Status is used during traversal of the graph. When a node is visited, it is marked with status of value 1 to avoid repeated visits. Data field is used to store the information of that node. Next, define a pointer to struct node called next. It is used to form a linked list of all graph vertices. Then, the pointer adj is declared, which is also a pointer to struct node. It is used to form a linked list of all adjacent vertices of current vertex. We also define various pointer variables like p, q, start, k, and l. Here, start is used to point to the first node on the graph. Then, let us move on to write the create function used to build the graph. Within this function, we declare a variable flag of integer type initialized to 0. Variable dat is declared as character type. Initially, null is assigned to variable start. Then, cout statement is used to prompt the user to enter the nodes in the graph. A value x is considered at the end of the list. Then, use a while loop with condition as 1, which loops infinite times. Within the while loop, we use cin statement to accept the value entered and assigns this value to dat. If the value entered is x, then we terminate the while loop using break statement. If the value entered is not x, then a new node is created and this is assigned to pointer variable p. Then we assign the value dat to the data element of the new node. Then initialize status flag to 0. The two pointers next and ADJ are initialized to null. Next, we use if statement to check whether the value of flag is 0. If flag is 0, it means it is the first node being created. Value of pointer variable p is assigned to start since it is the first node. The value of p is saved in queue for later use. Flag is set to non-zero value by incrementing it. If the flag is not 0, then the value of p is assigned to the next node of variable q and save p in variable q. After the while loop completes, pointer p is made to point to the start of the graph. Now, let us take adjacent node information from the user. Use a while loop to continue till end of the graph is reached. P is used as pointer to each node. Within the while loop, cout statement is used to prompt the user to enter adjacent vertices of each graph vertex. This cout statement also displays the value of the current vertex using the data field of P. Then, the flag is initialized to 0. Next, we use the while loop which iterates infinite times. Within the while loop, Cn is used to accept the data and store it in the variable dat. We use if condition to check whether the entered character is x. If the character is x, then we use break to exit the while loop. Else, a new node is created and assigned to k, and ADJ initialized to null. Next, we check whether the value of flag is 0. This condition will be true for the first time within the loop. If the condition is satisfied, then k is assigned to adjacent pointer variable of p. Value of k is then saved into another pointer variable L. Next, we increment the flag value to make it non-zero. For subsequent iterations, the flag is not 0. In that case, k is assigned to the adjacent node of L, and L is made to point to the new node k. A new pointer variable q is now made to point to the beginning of the graph. Using q as the pointer, we next navigate through the graph in search of the adjacent node data entered. A while loop is used to search till q reaches end of graph. The if condition compares data of each node pointed by q with dat. dat currently stores the user-entered adjacent vertex. If there is a match, then next pointer of k is made to point its adjacent graph vertex q. The loop continues by making q to point to its next pointer to search further. Once the inner while loop completes, outer loop progresses to the next graph node to read and store its adjacent nodes. Once all nodes are covered, return statement is used to return back. Next, we code depth first search utility function implementation for an unbroken graph. This function uses a stack to store the adjacent pointer of each node as it traverses through the graph. When it hits a cycle, it tries alternate route to traverse. When it hits end of the graph, it pops out last pushed adjacent pointer and sets it to the next adjacent pointer of that. It completes once the last pointer has been popped out. Within this function, initialize stack pointer sp to -1 and declare a stack of size 100. Next, we initialize p to start of the graph and cout is used to display the node data. Then we set the status to 1 to indicate it has been visited. Next, we define a while loop to continue infinitely till the break statement within the loop gets executed. Next, we use if condition to check if a JSON pointer is null. We will use this pointer k for traversing it to its next node, but save it in the stack for further exploration later. We increment the stack pointer and save the current adjacent pointer k. Next, we traverse to the next node pointed by this pointer. Next, we use if statement to check if status flag is 0. Within the if statement, we use cout statement to display the node. Next, we set its status to 1 to indicate it is already visited. Next, we need to visit this node's adjacent node. Set pointer k to adjacent pointer of node q. Then, we use else part. It is executed when the status of q is 1, indicating we have hit a node already visited. And set the pointer k to its adj pointer. Again, we use else statement, which is executed when k is null. That means end of graph has been reached. Within the else block, we check if there are any more adjacent nodes in the stack. We assign stack pointer variable to k. Next, we decrement the value of stack pointer by 1 and assign the value of adj pointer to k. If stack pointer reached negative, then it means it is empty. Break the loop execution. Next, we code depth-first search function implementation. It calls DFS utility until all nodes have been visited. In case of a broken graph, this function ensures to call DFS utility till all nodes are taken care of. Within this function, first we initialize pointer p to start node of the graph. Next, we use while loop, which sets the status of each graph node to 0, representing that those are not visited yet. Within this while loop, status flag is set to 0 and set p to the next graph node. Then we initialize p to the start of the graph. We use while to continue execution till it reaches end of graph. This while loop is required to handle a broken graph. Within the while loop, we use if statement to check status flag. If the current node is not yet visited, then call DFS utility with start node as p. If it is set to 1, then check the next node's status. Now, let us type in the main function. The execution of any program starts with the main function. First, use clear screen function to clear the screen. Call create function to create the graph. Next, cout statement is used to display the message DFS for the graph is. Then call DFS function to traverse the graph and display the result. We end the program with getCh function. This function prompts the user to press a character, but that character is not printed on the screen. This completes the program. Now, we will press F2 key or using cursor select File menu, then select Save to save the program. After saving, the program needs to be compiled to check whether there are any errors in the program. To compile the program, we press Alt and F9 and press Enter key. To run the program, we select Run from the menu or press Ctrl and F9. When we run the program, a prompt will appear asking the user to enter the nodes in the graph. Press X to exit. Say we entered A, B, C, D, E, F, X. Then a prompt will appear to enter the links to A. Say we entered B, C, D, X. Then a prompt will appear to enter the links to B. Say we entered E, F, X. Then a prompt will appear to enter the links to C. Say we entered F, X. Then a prompt will appear to enter the links to D. Say we entered X. Then a prompt will appear to enter the links to E. Say we entered X. Then a prompt will appear to enter the links to F. Say we entered X. Result of DFS is displayed as A, B, E, F, C and D.